Hey guys, I'm Mrs. Long. You are Geometry Geniuses, and this is number 15 in your interim assessment review. Now, remember, these questions are similar to what you'll see on the interim assessment, but not the same. Here, 4 students are working in a group and are asked to find the length of segment BC. I'm going to pull out my highlighter, and I am going to just highlight that. Now, we want to know which 2 students are on the right track. Our friend Joe wants to use the Pythagorean theorem to solve this problem. Sue wants to use the formula area equals 1/2 base times height. Now wait a minute, that formula sounds pretty familiar. Have you ever seen that before? Yeah, that's how you find the area of a triangle. We're not really interested in the shaded in green area. We're only interested in the yellow length between B and C. Therefore, that is not going to be the correct way to solve this. So I'm going to put an X there. This one up here, hey, I'm still thinking about it, so I'm going to put a question mark next to it. Notice I'm not scribbling through my answer or coloring it in, because what if I change my mind and decide to go back to it later? All right, my boy Carl is using the distance formula. That sounds like a pretty good way to find the length of something, so that's a possibility. Caleb estimates the length by counting the squares between B and C. Well, let's do that. We got 1, we got 2, we got 1. Gosh, I don't know. It kind of cuts through parts of some squares and not others. I know it's going to be longer than 5 because I can see that AB is 5, and I know that the hypotenuse is always the longest side of a right triangle. So I know it's going to be longer than 5, but that's about as good as I can do with my estimate. So it's probably not going to be that answer. So let's investigate the 2 where we put question marks just a little closer. The Pythagorean theorem. Remember, the Pythagorean theorem says a squared plus b squared equals c squared. All right, so the legs would be a and b, and the hypotenuse would be c. So let's see if that works. Let's try the Pythagorean theorem method here. Remember, we say a squared plus b squared equals c squared. All right, so here, A, I can just count from here to here. I can count that there's 1, 2, 3 there. So A is 3. So I'm going to substitute it in my formula here. 3 squared. All right, B, again, I'm just going to count squares. 1, 2, 3, 4, 5. We said that it was 5 earlier. So I plug that in. And I don't know c squared. That's what I'm looking for. 3 squared is 9. 5 squared is 25. Right? All right, so 9 and 25, we're going to get 34 equals c squared. I'm not interested in c squared, though, remember. I want to find the square root of 34, and that will tell me c. So, yeah, the Pythagorean theorem looks like a good way to do this. All right, but let's check. Let's check. All right, so this one, I'm going to change that to a check. That looks like a pretty good way to do that. All right, now I'm going to look at the distance formula. All right, well, the distance formula says that I can find the distance between 2 points if I take the square root of what? Do you guys remember what? Sorry, I'm still trying to figure out how to use this newfangled recording thing here. So the distance formula says x2 minus x1 squared plus y2 minus y1 squared. Now you may remember from your geometry class that the distance formula is derived from the Pythagorean theorem. So it's basically just the Pythagorean theorem written in a different format. If I look at this, if I were to call x2 minus x1, basically just tells me the distance between 2 points. Okay, so it's basically like using the Pythagorean theorem. So yeah, Carl here can use the distance formula, and Joe can use the Pythagorean theorem, and both of those will help him find the length of segment BC, or our highlighted hypotenuse there. All right, hopefully that'll help you on your question 15 as well.